takes a few seconds. Okay, you're on.
Thank you. Good afternoon then. So welcome to the Crux Showcase number 13. I'll take a quick opportunity to introduce myself as the new face over here. I'm the latest addition to the team. I'm joining a role, I guess, a role of many hats to start life, but focusing primarily on the sort of growth and further adoption of Crux itself. So it's going to be really interesting. This is my first month, so lots of learning thus far, and it's a great team to be part of. So I'm pretty stoked. So I'm also going to be joined by, I beg your pardon, today's speakers. So I'm assuming many people already know the people who are going to be speaking. We've got Jeremy Taylor, who's our head of product, also known as RefSet. John Pither, who's our CEO, and Daniel Mason, who's our Crux engineer. It has been a little while since we've had one of these sessions, so we've got a full agenda for you today. Instantly, I will be sort of popping up on various channels as well, so do pop in and say hi. I'm just going to share out my contacts on the chat as well, but please pop in. So I think to begin with, if I hand over to Jeremy, who's going to introduce the module changes.
Yep. Okay. I'm going to share my screen and dive into Emacs. Hope that's okay with everyone. Because that's always the best place to share things. So 1 second. All right. So yeah, I guess this is now sort of had a few weeks to bed in, and hopefully everyone on the call will be aware of this. But if not, let's just talk through the sort of implications anyway. So before the most recent change to Crux, we had like a different method for configuring the nodes. So a given Crux node could have many different configurations, and if you look at the diagram, you can see you can have ROX or LMDB or Kafka, etc. But what we've done now is to make the configuration of that simpler. So before we had this idea of a topology, and these topologies were these things you had to create in advance, and they were sort of semi-programmatic, but they had to live somewhere in a namespace. And the separation between the components and the topology wasn't terribly clear. So we had a lot of people sort of getting confused about why nodes weren't working properly, and invariably because ROX was configured for one part but not the other. So when the node tried to boot up, it wasn't able to see the docs, that sort of thing. So all of these requirements plus more led us to radically simplify the way that configuration map works. So now, instead of having something called a standalone topology and all these options, even if it all goes to memory anyway, we now can just start up Crux with just an empty map, and it will have a memory node. So these three key components in Crux, the document store, the index store, and the transaction log, they're now sort of very explicit in the map. So if we have a look at what it would have been before to have a ROX key value store, so basically having everything living inside of ROX, not necessarily a good idea for a high availability solution, because if your one node goes down, there's no way to bring up another node at the same time. So the data is only stored in one place. But it's certainly very useful for small deployments and prototypes, and in various other use cases. But in any case, in order to store a RoxDB topology, you used to have these extra configurations like this, where we're sort of expecting you to understand, well, what is the topology and what are the options it can accept? Whereas now, every time you start a Crux node, there are always these three components. And this is actually because of a change we made earlier in the year to separate out the event log into a explicit transaction log and document store, and that was resulted in the document store protocol. And now people can implement document stores more easily, as we'll discuss later. So in this case, we're defining a very simple ROX node, and this is what it looks like today. But the other critical thing is we're now able to add in new configuration options. So before here, if you change the configuration for your ROX instance, it would apply to all aspects of it. So the indexes, the transaction log, and the documents, it's all sort of tightly coupled. Whereas now you can say, well, for your index store, I really don't need to have sort of fsync happening every time we make writes to the key value store. I'm just going to let people in 1 second. Okay, I don't need to make writes every time to the key value store or have a write ahead log for the indexes, because there's no need if the indexes are always tailing the transaction log and document store anyway. But now, yeah, we can optimize so that each component has the optimum configuration for the given component. So if we want to use rocks for each of these places, we can have 3 different rocks configurations. We may want to add RocksDB monitoring onto one of them, but not others, which has valid use cases again, because monitoring isn't free. There is a sort of an overhead. But it basically gives us sort of more decomplected, to use that word, observability and the ability to pass options to very specific modules. And also it allows us to make sharing happen. So we can actually use this approach of, let's just use this the same RocksDB instance for all of these, equally for a JDBC backend, for a document store or a transaction log. You can make them share the same connection, so the same JDBC connection, as opposed to having to use 2 different connections, which has somewhat downsized, less sharing of the underlying resources. So this is great internally for how we think about modules. It's great externally for you to configure the modules, but it's also good for module authors, because it's much clearer now how to plug in your own module, add default options to it, and that sort of thing. So that's pretty much some changes on the topology. So I'm going to hand over to Dan now to talk about an example of one of those modules, which is the HTTP server. And some of the changes we've been making there recently are less to do with the configuration of the server, but it's more about what the server can accept and receive. And so up until now, Crux has very much been tied to the Clojure ecosystem in terms of supporting the Eden format as the format for data being ingested into Crux and being returned from queries. But we realize, obviously, being a database, that we don't want to be tied to a particular paradigm for data storage, which is really only got adoption in certain places and certain communities. So we've prioritized having JSON support for documents. So much like MongoDB or Elastic, where you can just put JSON in, we've now first of all, we enable string IDs, so your IDs don't have to be keywords or UIDs or URLs. They can just be normal strings, even empty strings if you want. Other things are supported, like ints and booleans as well, if you have use cases for those. But crucially, the ability to just put random JSON in, as long as it's valid JSON, it will be able to live in Crux, and the top level fields will get indexed. And I'll hand over to Dan to look at that.
Thank you very much, Jeremy. So as we've been talking about, I'm going to go a little bit into background on the HTTP first. So most modules in Crux currently are sat in a beta state, but the HTTP API has been sat in alpha. So there was a number of things we wanted to do first before we would be happy to commit to it as an API. So just a little idea of what it was like. There was a lot of handlers doing different things. So we wanted to bring kind of up to speed and up to date with more standard routing and middleware, ensuring that across the board it's consistent and simple, and handling parameters in a standard way and giving useful error messages. And as part of that, we brought in standard content negotiation, encoding and decoding. And as we mentioned, 2 new formats, JSON and transit. So the JSON work is currently still in progress, but I'm going to give a quick demo of just submitting some data, querying it back out and getting a document back out, etc. So I'm going to present my screen. Okay. Hopefully that's all right.
Yep, looks good.
Cool. So currently I've got a few tabs open in Postman. So I've got I'm calling to the submit TX endpoint, and I'm sending it some application JSON, just a few JSON documents. One thing I will note is that CruxDB ID in this case is kind of renamed, kind of mapped to _ID in JSON. So if I send that, that's now in Crux, and I get a JSON response with the transaction information. So I've got a couple of people here, and I'll query them back out. Now, currently, query on so we still have query posts, and we also have query gets. And currently, in terms of queries, the query itself needs to be Eden. So I'm sending in Eden, but I'm getting back out JSON in this case. So I'm just getting back the entity names, first name and last name. So again, their string IDs, first name and last name. I'll also show just a quick query with full results as well. So this is just getting documents back out again. Now, if I were to go to the entity endpoint now, I can ask for EID string James, and I want some JSON back. So I get his JSON document back out. And I'm just going to show quickly history as well. Just kind of give you an idea of like what the kind of a bit more of the JSON structure with a slightly bigger example, and then also like just an idea of how the endpoints look now. So I'm submitting, again, another JSON document. I'm submitting it into the past, and I'm just saying that James is a year younger at this point. So again, I get the transaction information back, and I can go to the entity endpoint. I'm saying I want history back. I want it in ascending order, and I want it back with the docs. So I get that back, and I get a JSON response with all that information. So yeah, quick little demo of just a few of the different endpoints, like submitting and query and entity. But hopefully that kind of gives you a little idea of what's been going on. And yeah, we're looking forward to getting that out there and finishing it off. And with that, I'll pass back to Jeremy.
Okay, so appreciate that's a lot of information in 13, 14 minutes. So I'll just pause for a moment. Does anyone have any questions on any of that? Otherwise, we'll dive into talking about queries for a bit.
So feel free to pop some questions on the chat as well if you'd like to.
Also, at the end of all this, we can just talk about Crux more generally if anyone wants to talk about their use case or just general ideas spurred from the conversations. We're happy to talk about that at the end. If not, I'll start my Emacs back up. Okay, so the next thing we want to talk about is observability. So this is again a change that has come in a change that came in relatively recently, but we didn't sort of make a big fanfare about it. I do think it's quite an important capability for a database because essentially when you're running Crux operationally, you want to do all sort of monitoring on the logs. You want to capture the logs. Maybe you want to elevate the logs for certain nodes or parts of your cluster, but in particular, your main interest is going to be, well, how is my node scaling? Assuming everything is fine, it's like how is my node performing? How do I plan for the the future growth of the number of nodes I need, and how do I optimize the way my nodes are working? So I have some examples here which sort of illustrate the importance of making sure your queries are fast, and then figuring out which ones are the fast queries. So I have a data set loaded up in my Crux node, so it's called my node, and I can do something simple like run recent queries, and basically it's not going to show anything that recent because recent queries by default only looks at like the first, say, 5 or 10 minutes of data, and you can configure that. But if we do actually run a query, so here we're looking at our data set. We've limited to the first 50 results in the data set, otherwise it would be a huge query and it would take very long. But we should now see, here we go. So we have a list of recent queries, and this can be useful for seeing what's the activity on the cluster. The other thing that you're able to do is to look at what are the actively running queries. So if you're in development and you accidentally ran a query that's taking a long time, you can look at your active queries to see which is the one that's gone wrong, which is helpful. And then the other one I wanted to talk about was slowest queries. So if we have a look at some of these queries here, I've got a default limit of 50 results on these queries. So this one, as I said, just queries generically, tell me all the entities in the database. This one is actually going to look at, show me all the movies in the database and then do an order by. So it could be quite an expensive operation, but if we run it, actually it returns pretty much instantly, again, because it's got the limit 50. So even though we're looking through the entire database doing a sort, we're still only taking out the last 50 results. Equally, if we want to do a projection and show me all the movies that where Brad Pitt is one of the cast members. It's not a long list. He has starred in a lot of movies, but it's no match for Crux. But what we can do is actually let's make the query more extreme. So let's have a look at show me all the movies, order them by budget, and pull out everyone that's in the cast at all for that movie. So if we run it with one, we'll get Pirates of the Caribbean. So that's the highest budgeted film. You can see the full list of people in the cast. So that's a nice query, but it runs very quickly, of course. And if we increase that to 10, it's going to run slightly slower. And if we increase it to, say, 1,000, you'll notice that even Crux is going to start to struggle with that, just simply because of the number of lookups that's having to happen. And for obviously long-running queries, you probably want to cache them versus blocking them for the user. But eventually, it executes. That's fine. Now, if we return to our list of recent queries, we should see a full list in here. You can see the queries are not formatted terribly well, but they are all in there. And if we look at slowest queries, we see that last query was enough to tip over the 5-second threshold that I added to show me the slowest queries. And then obviously as a developer, you can then use this information to start thinking about, well, which queries in my application are the slowest, and let's make those ones faster. Let's add some more indexing, I guess, around that. Let's restructure how I ingest the documents to create an index for it, essentially. So that's a little about query observability, and I hope you all agree that's quite a useful feature. So the next thing I wanted to discuss was aggregates. Now, this is something which has been talked about a long time. We actually had a module last year which added some aggregates to Crux as like a decorator, and it just wrapped the Crux API, and it had like some transducers and things. But we revisited this more recently, spurred on by our need to build some TPCH queries. And TPCH, for those who aren't aware, it's analytical queries which require a lot of aggregations, and also subqueries, which is the next topic. But in terms of aggregates, this is a classic example from the Datomic docs, but it runs in DataScript equally as well. And you can get the sum, the min, the max, the count distinct from the various monsters from Greek mythology. And that's a good demonstration of how those aggregates work to a user. So they live inside of the find vector, and they operate on a variable. And you can only have one variable. You can't do extra logic here. You wouldn't be able to do something else like this. So that's how that looks. And if you want to use that against our database, which I didn't really explain, but the movie database is a bit like IMDb, but a little bit smaller. So it fits inside a few hundred megs on my ROX disk. So here we can see we can sum the budget of all the films, and then this is happening in real time. So it's actually going through every movie in the database. Sorry, it's a popular showcase today. So it's going through every movie in the database and adding it up, and that's doing it in real time. So you can see it's almost instant. Obviously, there's some caching going underneath. ROX is keeping some stuff around efficiently, but essentially that's a reasonably expensive query. And you can see that if we then apply this sum to a calculated variable, so here we add profit, and we can see that profit is revenue minus budget. We can run the same sort of query or sum over everything in the database, and we can see, the total profit made by Hollywood over the last 100 years is, well, it's a large number, 255 billion or something, isn't it? So you can see that you can run aggregates in that sort of flexible way. And here, this is a definition of a custom aggregate, and you can define these via def methods, so closure only for the moment. You can see how they work. So we have sort of an initial state. This is the intermediate. So every time a result is found, it gets sort of aggregated via this incremental step. So here we're conjuring a value onto a collection, which happens to be a vector. So this is the vector, and we're conjuring it onto the vector. And then the final thing is, once the aggregate has been finished being accumulated, we then sort of produce it as a value. So actually we're accumulating it in order, and then we're reversing as the last step in this particular definition. And in order to define this, we can just do this from user space, in our own namespace like this. So we can define a def method on a sort of this internal Crux API, crux.queries/aggregate. And we see here, you can just define it and use it just as you would a normal aggregate. So here, this one is taking, for a given movie, show me the genres sorted in reverse alphabetical order. So family, F, comedy, C, animation, adventure. So that's an example of aggregation. And you can do more interesting things. And we've implemented average and standard deviation as well. I guess another key point to make is that this is respecting the laziness that Crux has, which is an interesting property. It's what allows us to do this this limit 50 and only take the first 50 results, because of the join order. The results are produced tuple by tuple, as opposed to taking all of the clauses and then doing these intermediate batch calculations over the intermediate result sets. So what's actually happening is that we're pulling out answers like var by var instead of clause by clause, and that allows us to do a limit 50, and it also allows us to do efficient aggregations. So these aggregations are happening as each result tuple flows out of Crux, as opposed to waiting to the end and then crunching down the numbers. So that's aggregates. I'll pause for a second. Anyone have any questions on that? Is there anything in the chat? I assume everyone can still hear me.
We can.
Okay.
Nothing in the chat.
No, great. Okay, so I'll move on just to talk about the something else we have in the pipe. So this hasn't been released yet, but essentially it's the implementation of in. So again, DataScript and Datomic have had this sort of syntax for a long time, and we basically just haven't prioritized it as a feature up until now. Again, motivated by our desire to build TPCH benchmarks, we needed subqueries, and subqueries really needed in to work. So up until now, you've probably seen we have this args concept, and what args really is a set of arguments. So it's a vector here, but really it's we're rerunning this query each time with new values, and then aggregation the results. So if I show you what the result for this is, we're looking for X and Y, show me all the different values of X and Y. And it's quite an obvious query. All it's actually doing is basically rerunning the query for each of these. And the key word here is that instead of X and Y being defined in like a simple way, we're actually having to upfront define the cross product. So each of these argument maps is like an explicit cross product. So if we want to come up with new combinations and add extra variables, the list of arg maps in the args vector is going to be huge. But it is what it is. But now we've added, as I said, motivated by the need for subqueries, but also the ability now to have destructuring from predicates. So I'll explain that in a second. But we now have in. So the same query, you see, you have to define X and Y, all the different combinations, the permutations there. Now we can just define these as relations, input relations. It allows us to more succinctly model what in really is, which is arguments. So that's how it works. There probably would be a question, which is like in DataScript and Datomic, you can add a dollar like that to add extra inputs. So Crux doesn't support that right now. So we are still only querying a single data source, which is more than enough for us to build interesting things for the time being. And then, I was just going to make the point that you can now destructure things as well. So the same syntax we have here for, it's very familiar for anyone that's familiar with Eden. We can now do something similar, actually inside of the where clauses, and then you can use instead of X, it could be Z, and then we can use Z to do something else. So just beware that's also supported. which then brings me on to subqueries. So subqueries essentially are the same as executing a query, then running another Crux query separately. The benefit of doing it as a subquery in this sort of inline syntax with the queue here, I mean, you could literally just take this and, yeah, as I said, run this beforehand as its own query and then feed the results into the next one. But the benefit is that the caching is shared. So every time you do an entity lookup, Crux internally is having to resolve the value of that entity and all its attributes and values at a given point in transaction time and valid time, and that is it's not a free operation. So there, it has to be an extra RocksDB or LMDB seek in order to do that lookup. So this allows us to share the caching, and you can still do things in here like I want to sum Z if you wanted. So you can then combine aggregates and subqueries, and this, as I said, is been critical for our work with TPCH, which we're using to drive new benchmarking and internal caching. So yeah, we can run this query and it should produce 134. There you go. So yeah, hopefully the syntax there is not too unclear, and it needs documenting still. So this is in flight, as I said. Okay, so that's subqueries. Any questions again? If not, I'll pass over to John to talk about Lucene.
Hi, everyone. Can you hear me okay?
Yeah, you sound good.
Just share my screen, my entire screen. Okay, then, so I want to talk about Lucene. So for those that don't know, Lucene is a full text search tool. So we want the ability to do wildcard searches. So right now in Crux, you can do an exact search against a attribute value combination within a document. But we want the ability to say, well, we want to do a fuzzy match like search where you have strings like this that test and then some other characters. So this is quite a requested feature, and we've been prompted by some real life usages of Crux where clients want it. So we've been building that. So we have a PR here that's in flight. The PR is currently open, so this is some work in progress, but it's nearing the end. So I feel like it's a good time to show it as part of this showcase. So I want to start off with how you would configure it. So this is the documentation that's in progress, and Lucene in Crux is a module. So here we specify a component, and this will be your Crux config here, and you add this Lucene node component, and then there's some boilerplate configuration here that is subject to change at the moment, but it should be as simple as adding a Lucene component, and then you will specify the directory of where you want the Lucene index to live on your local disk. So I want to switch to Emacs as well. So this is how it will look. So we've added a text search predicate, which builds on some of the work that Jeremy showed. Actually, the internals are kind of similar. Like this will return you some various tuples that match. So in this case, we're searching for the string Ivan across all of our documents that have a match for the attribute name. So if you can see up here, we're putting a document in, and we have the AV combination of name is Ivan. And then down here, this is our most simple basic test. We're testing that, yes, we get a match for that, and we get Ivan back, which is the ID of the document. So that's the most basic use case. We can then do some other sort of funky things that you get with Lucene. So down here, we have a fuzzy match. So here we're doing IV star, and as you can see, that also pulls back Ivan. And just because I can, I'm going to run this test, because it's always nice to see a green bar in a showcase. So there we go. There's lots more in the Lucene syntax that we can use. So for instance, here's one where we're saying, okay, well, we want to search for Ivan, but we don't know what that character is. And here I'm adding a different form of Ivan. And then here we do a check to make sure that we get both Ivans. As you can see here, I add Ivan, and then I get hold of the database before I add the new version of Ivan. And really, this bit of code here is just proving that the temporal resolution still works. So you can still query at a point in time and leverage Lucene in that process. So you can do, I want to do like a full text search, but at a point in time, and just get those results that are relevant to that point in time. So as you'd expect with Crux, that temporal resolution feature works. And so does eviction. So when you need to, we still make sure you can get rid of data from those Lucene indexes, be it some sensitive data. There is a subtlety here in that the Lucene index stores all of the temporal data, so all of the historic data. So as I said, you can query at a point in time. And we've been doing quite a bit of work just to figure out, well, what's the best structure of the index to make sure that that's efficient, so we benefit from structural sharing. So if you submit lots of documents and they're kind of similar, we don't want those Lucene indexes to blow up and be very big on disk. So we sort of designed this solution from the get-go with that in mind. Yeah, so there's not a huge amount to show. So I mean, the Lucene page, there's quite a lot in there, and there are various things that you can do. You can do proximity searches. In this version I've added, I've just got strings in there to start with, but in the future we could do like numbers and dates and things as well. So you really got that full power of Lucene behind you, which is just a really great addition to Crux. We've also got down here, I've got quite a few tests in here. And this one here, where is it? Where's my range search one? Oh, here we go, yes. So here I've got a test that we can query across different attributes. And this is a bit different to the way that Datomic do it. And admittedly, this is a little bit more experimental because we're diverging with a new feature. But here I'm not really specifying even the attribute that I want to search on. So this is like a search across all the attributes that might be in a document for a particular value. And of course, you can do all the fuzzy stuff and question marks and things here as well if you want to. If you note, actually, we've got a destructuring in place. So when I use my predicate like this, then I can destructure the results in terms of the tuples I get back. So this is the entity that matches. This is the actual value that matches. And with this predicate, I can also get the attribute, because obviously it can match on different attributes. On the main predicate, I don't have to destructure the attribute because it's known, because we pass it in. We also expose the Lucene scores. So if you want a score, it's as simple as just adding that and just putting that in the find expression. And then you can get the score for each match. Likewise with the wildcard one, we can stick S as well. So yeah, so that works quite nicely. I think there's some interesting questions on how far will this get you? Because when we talk to people that are using Lucene in anger, they typically want to go their own way with the Lucene configuration. So they might configure Lucene to use different stop words, configure it differently, the similarity, the way it's wired together. And they might even want to do very complex searches across different fields and using Boolean sort of combinations there to say, well, I want this search and I want this field and this field, but not this field. So what we really intend for these new predicates, these functions here, is to really give the user like an 80% boost in their Lucene journey. So if all you want is, well, we have the requirement and there's one field and we just want to do a full text search against that field for a document, or maybe there's like a couple of fields, or maybe you do want this wildcard functionality, but just in this one discrete case, then this will get you all the way there. This is a good solution for that. If you're building your business on complicated search forms, there's lots of different fields on those search forms, and you really need to get at Lucene, like to configure it in a way that you want to do so. Then it's our intention with this Lucene module that you really benefit from it being open source. So the fact that you can get in there and you can see how we've done it, you can see how we've wired in the Lucene component into the Crux topology, and so it listens to transactions and indexes those accordingly. You could take that and you could say, well, I'm going to, you know, in the bluntest case, just copy the whole thing and then do my own sort of Lucene integration with my particular configuration. Or what we might drive this PR towards is giving you the basic building blocks. So you can take the way that Lucene is wired up, so it ingests the transactions, and you might not want to mess with the way that we index the documents, but then you might want to plug in a different analyzer. You know, the way that we analyze the different fields and Lucene tokenizes fields, you might want control over that. Or you might want to make use of what's there, but then change the way the documents are indexed and then change the sorts of queries that you can do. And what we want to look at is sort of embracing the fact that this is open source and saying, yes, we've got like an 80%, we have an 80% solution here. But if you want that 20%, if you want to go bespoke, then don't despair. You know, you can look at the code, but we've also got some building blocks and some guides in place to say, you know, go your own way. And, you know, we've got some provision in there to help you. Yeah, that's all I've got. That was my agenda. Happy to take questions if anyone has any. No? Well, in that case, I shall hand back over to Jeremy or Steve.
Yep. Okay.
Pass to Jeremy. Just on that point, if there are any questions come to mind after this session, please do send us an email or find us on Slack as well.
Okay, so I'm just sharing my screen. Okay, so the next thing to discuss is Redis. So maybe it'd be interesting just to have a quick show of hands, or actually no, we'll do it at the end. But Redis is an interesting technology. I hadn't actually played with it much until about 6 weeks ago. I mean, I knew of it, but I hadn't really used it in anger. But then I had a vision late one evening, maybe in some red wine involved, and it involved Redis and this idea that, you know, right now RocksDB or LMDB, if you use it as a KV store, is very sort of coupled to a single instance of a Crux node. So your usage of Crux, in order to scale how you use Crux, you basically have to come up with full replicas. This is currently full replicas of a Crux node. Each RocksDB has to be an exact clone of the others in your cluster. And that could be expensive for certain use cases. So say you had 10 terabytes of data, you know, you would need, and you need 10 nodes, that's 100 terabytes of disk. Wouldn't it be great if they could all share the same key value store? Now, the reason why that's not already the case, you know, why we're using LMDB and Rocks, is because the way the Crux query algorithm works is very sort of chatty, and that means there's many sort of very fast successive key value lookups and seeks happening. So it's not as if you know, we do sort of one request to Rocks, we do, you know, thousands of requests, and for long requests, long queries, potentially millions of lookups. So every time you introduce any kind of latency into that process, query can suddenly become you know, much longer than you'd expect. So if you were to try and use like DynamoDB or something like that, a distributed key value store, even with all the indexing, you know, if the lookup speed is, say, 2 orders of magnitude, 3 orders of magnitude slower than Rocks, your queries, you know, are going to be 3 orders of magnitude longer, and obviously that means you're just pushing the problem elsewhere. For certain use cases, that can make sense, and we have had some interest in exploring like Dynamo or something as a KV backend. But Redis, I think, hits somewhat of a sweet spot, and that's because it's in memory first. Redis labs do have something called Redis on Flash, which is like a oh, sorry, I have a question. What was that question? Okay, Steve. Sorry. Yeah, Redis on Flash, which is incidentally is a layer of Redis. It's like Redis stacked on top of RocksDB, so it's kind of the best of both worlds. But that's proprietary, unfortunately. But the key thing is that yeah, because Redis by default holds all data in memory, you know, it doesn't try and persist anything. It's not trying to be durable. It's kind of perfect for a KV store in the same way that I said, you know, you don't have to have fsync or the write-ahead logon for Rocks. So Rocks, you know, of course, can cache things in memory, but Redis, because everything's in memory by default, you can be more guaranteed about the latencies involved in the lookups. So unlike a classic distributed key value store where things are probably being persisted on disk somewhere, we can be much more confident about the latency. And also, if you've seen that sort of latency chart by Jeff Dean, who wrote LevelDB, on which RocksDB is based, it discusses very clearly that actually in modern hardware, a network hop to a nearby machine and then getting memory, accessing the memory of that nearby machine. I'm not talking about RDMA, sort of direct memory access, but even if you have to go through HTTP to get that result from memory, it can still be quicker than like a reasonably fast hard disk. Now, obviously, if you have like NVRAM backed SSDs or whatever, there's a spectrum of storage technology. But if your only options are slow disk or very fast RAM, actually the very fast RAM, even if it's over the network, can end up being pretty fast. So in my benchmarking of this Crux Redis module, which I built over the period of a few weekends, even though we're putting things through Carmine, which is a Redis client for Clojure, everything's going through. It's not HTTP. It's like a TCP protocol, RESP they call it, RESP protocol. My benchmarking shows it's within 2 to 3 times slower than ROX. So it is slower than ROX, but crucially, it allows you to have infinite number of nodes. Obviously not infinite, but like a large number of nodes sharing a single KV backend, which for certain deployments, the economics of that can be really attractive. And we've also had conversations with people who, how can we deploy Crux on Heroku, for instance, because Heroku doesn't have like long running persistent storage where you could run ROX, for instance. But they do have hosted or managed Redis service. So Heroku's Redis service, it's not the cheapest thing in the world, but if you have a reasonably small amount of data and you have a huge scaling requirement, you're going to need 100 nodes to spin up in 10 minutes. Actually, Redis could be a really natural fit for that model. So even though you have slightly slower queries, there's a trade-off, a spectrum of trade-offs here. And then I was chatting to Dominic Monroe, who is an ex-Juxta, still very much a Juxt friend, and he's working at a company now as a CTO. But he was at the weekend building another sort of Redis backend. So instead of using Redis as the key value store, you could use it as a transaction log and or document store. So the use case here is slightly different, but the combination, of all three is that you can use Redis for everything. And you may be thinking, well, Redis as a transaction log sounds a bit unsafe, but actually Redis does have a sort of like an fsync like option, so you can make sure all your writes are always written to disk every time. And in a distributed setting, you can make sure that you have some level of high availability across redundant machines. So it's there's not a lot of code in these modules, so it was interesting to spike it and also to prove how easy it is to build these modules. There's not many methods on the KV iterator protocol. You have a seek, you have a next, a prev, a value, and that's it. So if you can figure out how to fit those into your backend of choice, whether that's Google Firestore or whatever, what have you, there's a lot of ways that Crux can be assembled to meet your non-functional requirements as much as anything on your cloud platform of choice. And I believe we have the author of Crux Azure Blob Storage as well on the line. So hello to you, Henrik. So that's basically all I wanted to say about Redis. I wasn't going to give a demo as such, so that we could potentially do that since we have a bit more time left. Yes, I'll head back to the call to stop presenting and see if anyone had any questions. Has anyone thought about perhaps building a back end for anything? Does anyone have any burning requests for new module implementations?
We have 2 questions in the chat, Jeremy.
Oh, yes, we did. Yeah. Okay. Carmine still doesn't support clustered Redis, or does it? Yeah. So that's correct. So Carmine doesn't support clustered Redis, and I reached for Carmine because it was just convenient. I figured, well, it'll be quick for prototyping, but actually I haven't used any of its features, and because it already uses Nippy, because Crux already uses Nippy, the actual value Carmine offers isn't very much. So it's actually absolutely plausible to switch it to using Jedis, which is the Java Redis client directly. The other thing I wanted to mention was, I mentioned this Redis protocol. Well, in theory, like Redis can be used with something which isn't even Redis itself. So there's like RDB, and that's ARDB, and there's a few others which have like added Redis compatibility. So even if you don't want to implement your own KV store, you could find something that implements the Redis protocol and plug that in. So there's multiple levels of protocols going on here. So yeah, keen on not having your Redis indexes replicated, so Redis is a good choice. Yeah, that's great. And there is actually another exciting development which caught my eye a week or two ago, which is that the RocksDB Java client, which we use, has added this support for like an open as secondary feature, which kind of does a similar thing to Redis in that it would allow multiple nodes to read from the same RocksDB instance. Obviously, if they're shared over a network file storage. So hypothetically, it's possible to do it with Rocks as well. So that's sort of on our agenda to test and benchmark with at some point. And maybe that'll be faster because it doesn't have all the protocol overheads. But then maybe the network file storage protocols are slower. So we'll see. But potentially that could allow running your Crux nodes in like Lambdas and then using like Elastic File Storage as the thing holding Rocks. And of course, you'd have to have only one writer writing to Rocks at a time. But assuming you can model that in your topology or your clustering, it seems like a reasonable thing to try. Okay, next. How do we manage replicating indexes across multiple nodes? Yeah, so I guess this is kind of the 101 of the architecture. So by default, nodes don't know anything about each other. All they know is there's a transaction log and a document store. And any sort of communication that happens between the nodes is essentially writing to the log and the document store. So nodes are almost fully independent, and therefore the availability of nodes doesn't really matter. It's all about the availability of the docs and the transactions. So they each have a full replica.
But Jeremy, is it worth mentioning about the backup and restore snapshot functionality that's coming out?
Yes, as well. Yeah. So and the backlog. In fact, Steve, did you have the slide of the project board? You could just put up.
Yeah, sure.
Essentially, So James has been working on this new checkpointing capability, which we did already have at one point, but we've now made it sort of more uniform and implemented it as part of the protocol. So you can take a checkpoint of the indexes persisted up to S3 or whatever blob storage you like, and then when a new node comes online, it pulls down the latest checkpoint it can find, and then it will replay the transactions to the most recent. So it'll bring the node online gracefully. So that's how that works. So what else do we have? Stephen's excited about the Lucene module. That's good. David Harrigan. Celtus. Okay. I haven't seen that one. Interesting. Thank you.
C lattice.
Say it again.
C lattice.
C letters.
Yes.
Okay. I think I prefer Celtus. Okay.
Celtus.
Cool.
Let's go. Yeah, I use that in my production systems with clustered Redis setup, and it seems to work okay. Okay,
great. Good to know. Thanks. Yeah, I can't remember why I first went to Carmine, but anyway.
No problem.
Do appreciate Peter's work on Carmine and Nippy, so shout out to Peter. So Alexis, the blob store is actually just in the Crux repo now. So if you go, it's like a Crux Azure blobs. That's that. Mark says, are there thoughts of distributing queries among nodes, complex SQL queries for analytics? So essentially we're not looking to tackle this problem, at least not in like the near term, like next year or so. So the idea of so there's one thing having a distributed database where your data is distributed, but distributed queries, the only database, like graph database I'm aware of that's tackling this is dgraph, and it introduces a lot of problems because it's a question of, well, how is the data sharded to match the the query sharding patterns, but also how does the availability of the query nodes work, and how do they divide up the work between them. And it's a much more complicated problem to try and tackle as a relatively small team that we are. It's not an uninteresting problem, and certainly there are a lot of use cases for big graph analytics. So it's something we're interested in, especially like there's a lot of research happening around temporal graphs. Temporal graphs, which of course we model in some way by temporality, and the all this research, academic research around temporal graphs is all about tracking movements of people and cities and massive data sets. So it would be lovely to be able to have a temporal data log query language that can execute in a distributed way. But yeah, right now you'd have to sort of roll your own, decompose your queries into subqueries and run your queries on nodes which contain the shards of data you're interested in, and assemble that up in your query language. So we don't have a solution for that. We do, however, have Calcite support. So theoretically, it's possible for Calcite to do some of this work. I mean, this is part of Calcite's sort of value proposition to be able to go to multiple backend stores and figure out the join order for how to push queries down to those stores. So there might be like multiple round trips involved, and then aggregate the results. So our Calcite module doesn't do this today, the one we use for Crux SQL, but it is possible that you could do that with Calcite, although it doesn't handle the sort of failure modes of doing that sort of thing. Okay. Was there anything else anyone wants to discuss? Does anyone have any new or interesting thoughts about Crux, or wants to share what you've been working on? I could say I was chatting to, I don't know if Alexis is still on the line. He is, yeah, about Metabase earlier in the week. So we are reviving that. That still works. Thanks to him. There was a small change that got introduced which made it didn't work. So sorry to anyone that's been trying to get Metabase working. It's been scratching their heads. So we will hopefully provide like an official driver for that at some point, because we're keen to play in that sort of ecosystem. People like their dashboards. Otherwise, I'm happy to wrap up the call in a moment. We will be having a new release in the not too distant future, and including some of the changes which you've seen today. So thanks for listening. I'm going to stop the recording now, and we can have a bit of informal Q&A as well.